Yeah, so today we're going to do a small workshop about how to use Pragma. We'll stay like very basic, like how to use it, very simple. So the outline of this workshop is the following. We first look at how to use Pragma using the Pragma hack repository that we created to like make it very easy for you to use Pragma. So for the ones who do not know, Pragma is currently the best way to get any financial off-chain data in your Starknet contract. So we're talking about prices of different assets, which you can find the list here, and more are being added. So you have spot assets, you have future assets, stable coins. You can rebase and like jump, create new pairs, and you also have computational fields on top of that, so realized volatility, yield curve, TWAP, as well as the randomness with the VRF. So we'll see a bit how to use all of these in different ways. So the first thing I'm going to show is how to use this handy Pragma hack repo. And the second way is by using Remix, which I think is very it's widely used in the EVM world, and it works pretty nicely with a Starknet plugin. So we'll also take a look at this. Okay, so let's start. I've created this workshop repo. So the easiest way you can really start using Pragma is by simply cloning this repo. So that's what we're going to do. Just clone this repo. If you go into it, so it's a standard SCARB project. So let's take a look. So I assume you have some knowledge of how to build Starknet contracts, but basically you have this scarb.toml file that just tells you, okay, here are the dependencies and some other settings, but yeah, the main thing is really the dependency and the Starknet version that you'll be using. And then we have two things. So right now, Pragma is alive both with the Caro 0 version and the Caro 1 version, both on mainnet. Yeah, I think there's a question. Should the repo URL? Yeah, sure. There you go. So if you want to follow along, there it is. So I was saying that there are two versions live on mainnet currently, a Caro 0 and Caro 1. Both have been audited, but the Caro 0 version will soon be deprecated. So if you're going to start right now, just delete everything related to Caro 0 within this repo. You can delete this, and you just have the Caro 1 version, which is the main one that is going to be maintained. All right, so once you have this, here is a very simple example about how to use Pragma. So if you're not starting from this template, but starting from a new project, you might want to do something like scarb add Pragma git, but that's not really the best way. Like, I don't recommend doing this, since you don't really need like the whole repo with all the contracts and everything, and you don't need that. Like, the minimum thing that you need are here in this Pragma.Caro contract. And you probably don't even need that much, right? You can just define the Starknet interface with the methods you need. So let's say you just need get data with USD Hub, or get data, which is like the main one, or you can just define your interface with only this one. So you would do Starknet interface, define your trade. So my Pragma API with some contract state, and you just put the functions you need, right? There is no need to overcharge with useless functions. So pretty much how you would do it. And then within your contract, you just need to import mainly the dispatcher and the dispatcher trait. So those are the two main things that you need in Cairo to interact with another contract. You need the dispatcher and the dispatcher trait. These are automatically generated from an interface thanks to the Starknet interface macro. Yeah. So let's take a quick look at this contract, and afterwards we will deploy it using Remix and interact with it, and you will see we'll see in practice that it works. So this is the structure of a Starknet contract. If you're not familiar, very simple. You define Starknet contract, you define your storage. So here we just store the addresses of the Oracle contract and the summary stats. We'll go over the summary stats later. Let's just focus on the Pragma contract for now. And in the initializer function, it's initialized to the correct address. So we have a few functions here just to show a bit how it would work, and in practice how you would be using it. At the end of this workshop, I'll also show some examples of currently live code bases on Starknet that are using it and future developments. So the first thing is to define the Oracle dispatcher. So that's how you interact with any contract on Starknet. You define your dispatcher, and then you can directly use any method on the ABI that you define. And the most classic one, I would say, is to get the median of some data. So let's say you want the median price of ETH USD against USD, and you just do that. Let's say you would want Bitcoin USD, then you can, or Sol USD, you can totally do that, right? Let's say you want future data, then very simple, you just change here to future entry, right? So that's just as simple as that. So for future entry, you need a second parameter, which is the expiry timestamp, right? Because future data have an expiry, right? These are contracts, you have perps, and you have contracts that actually expire. So you call the Oracle contract with get data median. Let's say you want, for whatever reason, you don't want to use a median, but you want to use another aggregation scheme. So right now we mostly have median and mean, but in the future we'll have more. You can simply do this. So aggregation mode, column, median. And so that's the equivalent of what we've seen before, but you also have mean. And this will aggregate all the data entries using a mean instead of a median. That's, for whatever reason, you could specify this, and in the future there will be more available. So let us know as well if you're interested in other aggregation methods. That's very important for us. Okay, so when using get data, you actually get the data for all the sources that are publishing to Pragma. So right now we have a bunch of market makers and also external API sources. So we have DeFi, Coinbase, market makers such as Forlip, Skynet. We have a bunch of them. But let's say you only care about DeFi Llama and Coinbase. Maybe those are like the only sources you trust, and you don't want your data to be like polluted by other sources, right? Then you have the get data for sources method, and exactly the same. You specify the data type, the data that you want, the aggregation mode, so median or mean, and the sources array. So very simple. All right. Once you've got your data, you can get so it returns this object, this Pragma prices response object. So you get the price, you get the decimals, you get the last dated timestamp, the number of sources aggregated, and the expiration timestamp if you ask for future data. So usually what you might do, like in real practical use case, and we'll take a look at that later, is actually check the you can check that the timestamp is correct, right? So you get the timestamp and you output that timestamp, and you check that it's like in some range of the current block timestamp. So let's say like more like superior to greater than get block timestamp minus 100, right? So it's last updated timestamp, right? And here you have an error that not fresh or whatever. Yeah, so that's a basic check that you definitely want to put in your actual DeFi app, right? You don't want to you don't want to end up with incorrect all the data. So that's one check you can do. One other check you might want to do is also to check the number of sources that have been aggregated. So we already have a sources threshold incorporated in the protocol. So if you go look at the contract here, it's called Starknet. If you go look at the contract, there is this get sources threshold, which is currently set to 0 on testnet, but to 3 on mainnet. But you could, let's say that's not like satisfying enough for you, then you probably want to assert same thing, that the number of sources aggregated is greater than, let's say, 3, and have like not enough sources, right? Okay, and you can probably do more checks with all the things that are returned. Okay, so now that we have this, it's important to normalize the price that return you has a certain amount of decimals, right? So, for example, if we get data median, so here I'm using a very handy tool, a Raycast extension developed by Upwork that just lets you convert. Okay, so I introduce 0 because it's an enum. And you can see here the value for the price is this. So we have this, and it has 8 decimal, right? 1, 2, 3, 4, 5, 6, 7, 8. So this is the price of ETH, but you might want to multiply some threshold by the multiplier. So any operation that you're doing, you have to do it in the same scale that the data that we returned you, right? So maybe your protocol has 18 decimals precision. Well, you got to make sure that you're doing operation with the same precision. So here we just want to have some threshold, like say, hey, this function should return true if the price of ETH is below or above a certain threshold, a certain price. Then we have to multiply by the decimals of the price, and that's it. Here, very simple function that just returns the asset price, and so I guess let's do a first demo in Remix of this, and then we will go through the summary stats, which I think is one of the most interesting use cases of Pragma. But let's first look at this in practice. So in our documentation, you have this getting started consuming data feed section. Like very handy. We go through all the process of explaining pretty much line by line, like I'm doing right now, and even in more details, and deploying this to Remix. You have this button open in Remix here. And so in Remix, you have this Starknet extension. If you go there in the bottom left corner and you activate the Starknet extension, then now you'll be able to compile, deploy, interact with Starknet contracts within Remix, which is pretty cool, given that's like one of the most widely used tools out there. So already prepared a little something here. So the quick start contract I put in Remix is basically this one that you can find in documentation. Let me also send the link here. All right. And so, yeah, so it's basically here. Same thing that I've just shown to you. And let's compile and deploy this. So you click on compile. You can select the compiler version that you want to use. Just recommend using the latest one. And then you need to put, so in the constructor of the contract, right, we have the Pragma address and the summary stats address. So let's find that. So you can go there and you have the address and consuming data. Okay, and for summary stats address, we'll go through that later. Maybe we'll put it right now. Yeah, no, let's not care for now. So it has already been deployed, but basically you can connect your wallet here, your Argent or Bravos wallet, and you can deploy it on testnet, even mainnet. So that's very cool. You can also deploy on local DevNet or remote DevNet. But the problem with that is that you will not have access to the deployed contracts. So here I deployed it on mainnet. And then I have access to this get asset price function that just calls the data median. And let's say we want Bitcoin USD price. There we go. So it's here in the logs, and we have the result. You can see here, it's the Bitcoin price with 8 decimals. All right, so that works pretty much fine. You have a bunch of other functions available, like if you want to just quickly interact with the contracts, you can also go on Starknet or Voyager. So because it's an enum, the tricky thing is that you need to put first like the data type, so 0 for spot, 1 for future, and then the pair ID. So the pair ID is just the string converted to felt. So I highly recommend you install our charge.dev. That's different. This one. So I'll put it here. It's the Raycast extension that can let you just quickly switch between, do conversions between values, felt, hex, even get function selectors right from your computer. All right, so now that we have seen basic interactions, let's look at more complex kind of data feeds. So for that, we'll go in the documentation. You have here an explanation about what are computational feeds. Basically, you can think about it as, okay, you have a bunch of raw data. So you have a bunch of people that publish some data, like the price of Bitcoin, with the volume and all this kind of stuff. I'll go here to overview. Right, so you have a bunch of people that just publish data, Argent, Spatial, market makers, brokers from different sources. And then you have some aggregation that gives you the final data stream. And realized volatility is one pretty cool thing. So usually before in blockchains, if you wanted to compute the realized volatility, you would have to do it off-chain, right? Because it's a lot of computation. But the cool thing with Starknet and Caro is that you can actually do that on-chain directly. And so you remove like a whole vector of trust assumptions. So let's take this compute volatility and go through it. So we have the formula for realized volatility is basically this. It's a square, it's an average of the log, the squared log of the price differences on the time differences. So all of this is already coded in Caro. You just have to call the calculate volatility function on the contract. So maybe let's go on the all right, so let's see here. Okay, let's go to this one to see how it works. So there are a few parameters to give. The first one being the key. So the key is, again, let's say if you want to realize volatility of USD, then the start. So the start would be the current timestamp, which we can get here. Right? The start, then the stop. No, the stop would be the current timestamp. The start we can have, like, let's say 1 week before, like 5 days before. So here. All right. And the number of samples, that's like how precise do you want the computation to be? Because if we go back to how it's computed, yeah, right. So you need, like, how it works is basically anyone is able to call a function on the smart contract called set checkpoint and set checkpoints. So when you call set checkpoint, you like take a snapshot, you know, of what's the state of the market at this timestamp that you're calling the function. And the more checkpoints we have, the more precise we can be about the computation, because the more samples we have. So number of samples, let's put 20. So probably this would fail because we don't have a range big enough, and I'm not sure there has been checkpoint set right now. So let's try maybe with Bitcoin and a bigger range. Sorry for this. A bigger range. So let's go. I don't know. Let's go like last month. Right, and we can put yeah, so probably there haven't been any checkpoint sets in the past, but that's basically how it would work. So it's not more complicated than this. Yeah, so in code it looks like this. You get some start tick, some end tick, some number of samples, and you just compute the volatility. And yeah, as simple as that. So that's one feed. The second one we have is the time-weighted average price, so the TWAP. Again, it works pretty much the same way. So let's see, this one work. Put the key. Start, stop. No, this one might be because of the same problem. So you need to set some checkpoints for these to work. We have an example of how to set checkpoints, but yeah, if you need these checkpoints, just let us know, and we can run keepers. Carmine Options, for instance, is running some of these keepers. Yeah, so it's fully permissionless, so anyone can set checkpoints. It's just calling a function, and then you can use the checkpoints to compute these kind of feeds. So the TWAP is same thing: a start tick, an end tick, number of samples, and you compute the TWAP. So as simple as that, and you can get way. These are just an example of data feeds that you can build using Pragma. There are a bunch of them. You can be as creative as you want. All the raw data is basically present on chain. So if you go there in read and you get data entries, so for Bitcoin, if we get data entries, we can see that's all the latest data entries, right? You have a bunch of data from a lot of sources. For each of them, you have the price, the volume, who published the data, from which source, and you can already do a lot with this data, and we are adding more and more data as time goes on, but One last thing I wanted to show you is the yield curve. That's a fairly interesting one. So in lending protocols, basically the borrow rates, the different rates are set manually. Like you have these rate curves that are like fixed in time. But the problem with that is it doesn't really adapt to the current state of the market, right? It's not very accurate. So in traditional finance, you have these things called the yield curves that are actually widely used, and that's how you define define the different rates across a time range. And we coded that on-chain directly, so you can use this yield curve again very easily. So you just call the get yield points, and that's it. So right now it's sourced from the Aave overnight rates, but we're open to discussion for implementing that for other markets, such as Curve or other markets. And you can easily use that to implement like fixed rate lending on top of Aave or other kind of primitives, just to make lending more efficient, or any other thing. You can be as creative as you want there. Okay, so that's pretty much it. You have the example here in the Pragma hack repo. In the documentation, you have a lot of code examples as well. All right, so I think the one last thing I wanted to cover for this workshop was the randomness, something we recently released on testnet, and you can use right now. It's the randomness. So I have a example randomness contract here. So if you want to get some random number in your Caro contracts, that's also very simple. Using Pragma, you just follow the steps here. You can just copy paste this code actually. There it is. So you can just copy paste this example and start from there, or just take whatever you need. So how it works, it's basically you need to request some randomness from us. This will emit an event, and we are basically listening to these events and fulfilling the request. So there are a few things to take into account. First is that you need to send some ETH to the contract that is to your contract that is requesting randomness, because we will call back into your function. So you have everything is explained in the docs as well, probably way better than I do. But you just need two things. You need to request call the request random on our contract, and define a receive random words function in your contract, right? If there is no receive random words function, it won't work. It cannot work. So these are the only two things we need. So here's an example of how to use it. We just approve, you approve our contract to use your ETH. Then you request some randomness. So you need a seed. The seed is just to some random number to like any number to just have some more randomness. The callback address, so it could be the same contract or it could be a different contract that has this receive random words function. Callback fee limit, that's a bit of a tougher one, but basically it's like a limit of how much you're willing to pay for us to call back to like fulfill your request. Then you have the publish delay. So that's like how many blocks do you want your request to be fulfilled? Maybe you don't want your request to be fulfilled like in the next block, but you want it to be fulfilled in like 10 blocks or 100 blocks. Let's say you want to have doing some pull together mechanism and you want the request to be fulfilled in 1 week, then you can just put 1 week here in the delay, and it will make sure that the request is not fulfilled before a week. And finally, the number of words, so that the number of random numbers that you basically want. All right, so that's how you do the request. And in the callback function, you can technically make sure that it's our contract that is like calling your callback function. Otherwise, like anyone could just call it, and that's probably not what you want. Then you can check the block number, so make sure that the publish delay has been respected. You could also check that the requester address, I mean, it's that it's you that actually did this request, right? And it's not someone else that did a request for you using your contract as a callback. It's probably not something that you want. I mean, you might want that. It depends really on your use case. And then you just access randomness using random words at 0. So you have an array of random numbers, and you can store that in your storage. You can toss a coin, roll a dice, play a game, do whatever action that implies some randomness. And this randomness is like fully secured, meaning that anyone, when we are fulfilling a request, so I'll show you an example. If you go to our testnet contracts, so here there is an example of someone doing a request, and when we fulfill a request, there is a randomness proof event that is emitted with the proof of the randomness, and anyone can just take this proof and verify it off-chain, right? So you don't really have to trust us. I mean, we have no incentive to publish wrong data, because anyone can just verify that it was wrong randomness. And for this, we have some utils in our SDK. So everything is written in a doc. You can just install our SDK, verify the randomness, given a transaction hash. And yeah, that's pretty much it. Yeah, I think we've covered a lot of things. Edward will also send you a bunch of ideas on how to use Pragma, what you can build with. We have a bunch of things that are just waiting to be built.
Yeah, exactly. And also, if anyone has questions, feel free as well to ask them now or in the Telegram chat.
Yeah, if anyone has questions, I'm happy to hear. Maybe dive deeper into some subjects, or yeah.
So my question is probably quite silly, but I'm asking, how do you add Pragma as a dependency? Because I tried to use like the GitHub things, but I'm not able to use that.
Yeah, so that's what I answered a bit at the beginning, but you might not been there. Basically, so let me show again my screen. Yeah, so if you're trying to do this, carb add Pragma with the Git link. That's probably not the best way, because it's like when you do this, you're actually adding as a dependency all of our contracts, right? And that's like useless dependency. So the recommended way is just to use our Pragma hack contract. You just use this interface here. This has everything you need. Like, to interact with Pragma, you don't need more than just this file. So you don't need to, and you can probably simplify that way more with just what you need, right?
Okay.
So
I just copy that.
Yeah, you just copy that and you remove what you don't need, right? Here we define the whole interface with all the functions, but as I showed, like, let's say you only need get data, then you can just define your ABI with get data and you just remove everything else, right? maybe like it could get very, very simple. Let's say you don't need checkpoints, where you remove checkpoints. You might don't even need that. You might, so everything is in this file, but in most cases, you will just need data type and aggregation mode. I think those are like the main things you need. Yeah. So I hope that answers your question.
All right, thank you.
Yeah, you're welcome. But we will create a card package that is that you can add as a dependency and that has only the things you need.
All right, that will be helpful too. Well, thank you.
You're welcome.
Great.
Are there
Someone else?
any other question, maybe on the randomness or the feeds? Maybe Edouard, I don't know if you have some examples as well of things that can be built, a list maybe that we can send to people.
Yeah. I have a list for, this was like more for the randomness, focus on games. But otherwise for the, I know that someone here, okay, is building a prediction market using our price feed. That could be as well interesting. Any as well like DeFi products using, of course, like realized volatility or the yield curve is also super interesting to build. You mentioned like a fixed rate interest rate, fixed rate lending protocol, which hasn't been built on Starknet so far and has some traction on mainnet. So that could be as well super interesting to build.
Yeah, especially around the risk engines, like a lot of things you can do with all this data. Like there are a lot of, just think about the parameters that are currently manually set within DeFi protocols, like debt ceilings, interest rates, all of these things are just manually set. And think about how you can make these dynamic, have actual risk engines, so that these parameters like react based on the market state, based on the volatility. Yeah, that could be very efficient and more efficient in most cases. And we can do that because we're building on Starknet, and that's the cool thing, right? We're not constrained to the EVM anymore. We can do way more stuff.
Yeah, I shared here in the chat that what you mentioned. We made a little like few case studies on debt ceiling, dynamic state ceiling. That's definitely as well interesting to build. But if you're missing ideas, feel free to ask us as well in the chat about the architecture of how you want to build it. We're happy as well to help on that point. And yeah.
Yep. All right.
So if no one has a question anymore, I think we'll wrap up. Thanks for everyone to attend this workshop. Hope it helped us and enjoy hacking.
Yep. Let us know if you have any question in the Infra hack chat. And thank you very much, everyone. Have a nice day. Bye.
Bye.
Thank you all for the workshop.
Thanks. Bye.